the first rule of factoring has always been GCF, right?
Yes.
Yeah.
So the first one here, it's pretty straightforward.
Oh.
Take out the 4x, and you're left with x minus 6, and you're happy because it's done. Now, when it comes down to the other one, you have to remember how to set these up. When you're, what's that? We've done them before, but remember what happened when you did those last time?
You don't lose. That is a trap.
So, once again, as we look through here, you multiply your outsides. You have a trinomial with a leading term coefficient that's not equal to 1. You got to multiply the outside parts. What times what's negative 42 that adds together to a positive 11? Negative, yeah, positive 14, negative 3. Okay. So you have 2x squared minus 3x plus 14x minus 21. You're turning the trinomial into 4 separate terms, so that way you can factor by grouping. This was a skill that we worked on a lot with quadratics again. This doesn't go away when you're going back into higher order polynomials. Okay. This doesn't go away. You have to know your multiplication facts. You got to know your stuff like that. One of the things that I've done that I normally do is that if I have a positive and negative value for the middle terms, I generally write the negative term first because I'll be less likely to screw up a sign later. Okay. Yeah, Cliff.
If we have 5 terms in polynomial, would you ever have to split the middle term among those 5 so you can make 2 trinomials?
Usually what happens is there's usually not going to be a 5-term one. More often than not, we're looking at 2, 3, and 4-term polynomials with different degrees.
Okay.
Okay. Yes, sir.
In this case, I think that you might want to switch the 2. Otherwise, you can't really factor them.
Yeah, again.
You can only factor the x out of that one.
Hold on. And Clint, I'll show you a better trick when you get to 5 terms because it's even easier. Group them.
Just that.
Yes, sir. Group them. What's your GCF?
X.
Factor out the x. You got 2x minus 3. What's the GCF of 14 and 21?
7.
Are these two the same?
Yes.
Write it down.
Oh, I got it. X plus 7.
Very good. Because we do all of these same exact skills with higher ordered polynomials. Okay? We're going to do all this with higher ordered polynomials. Here's what happens. We jump right into grouping. I'll just rewrite, it's easier. Yeah, it was. So right off the bat, we jump into a problem that's a higher degree polynomial. I have x cubed minus 2x squared minus 9x plus 18.
Just group them, right?
Yeah, and that's one of the things I wanted to talk about real quick here before we get too far in this. Remember when you're working with factoring, when you're working with factoring, there's kind of like a generic skill set of things that you go to do as you're working through it. One of the first things that you would always look at with factoring is, let's see, our factor how-to, if you will. If we're looking at a factoring how-to, the first rule for factoring is always to do what? GCF. So when I'm factoring, no matter what it is, however many degrees, however many terms it is, I'm always going to look for a GCF first. After I do that, then I start to think about all the other ways I know how to factor. So I'm going to factor it somehow.
Some genius.
So what I'm saying about this factoring somehow is that you guys know a bunch of little ways and little tricks. For example, you know a difference of squares. You know difference of squares. What's the rule for difference of squares? How many terms do you have if you have difference of squares? You only have 2 terms. Both of them are perfect squares, and what's between them? Subtraction. You know difference of squares. You know difference of cubes. Oops. You know sum. a cube. We just did that yesterday. You also know how to factor a trinomial. Multiplying the first term times the last to get you to the middle. Splitting into grouping. All of these things have their place when we're factoring polynomials, depending upon what they look like. Okay? So in the example I have here with this x cubed minus 2x squared minus 9x plus 18, since it's given to us as 4 terms right off the bat, which of these methods do you think it's leading you to? It's leading you to grouping. It's leading you to grouping because grouping is usually done when you have 4 terms. So if I'm looking at this here, I'm just going to group it where it's sitting, but what am I going to do to remind myself of something, that third part?
Including negative.
Yeah, include the negative. Do a same change opposite there with that negative. And once again, the reason that I do that is so I don't screw up my GCFs here in a minute. Okay? So, x cubed minus 2x squared, what's my GCF? X squared. I factor that out, and I have x minus 2.
The other one I got negative 9x minus 2.
Right, negative 9 times the x minus 2. So, are the two terms that are in parentheses the same?
Yes, sir.
What do you do then?
Solve for zeros.
Do you see an equal sign, Cliff?
Yeah, there always is. You always pretend there's an equal sign.
Not today. Now, I'm factoring this, so am I done?
No.
Why?
Just
Very good. In this case now, since we have a third degree polynomial, sometimes you might wind up with 3 separate terms. So here I have a difference of squares. So x minus 2, x plus 3, x minus 3. And that would be a fully factored form. That's it then. Yeah, because the only difference between this and an equal sign would be that I'd have to find my zeros. Okay? There's no equal sign, so all I'm worried about is just factoring it completely. Okay? Shh, gentlemen, come on.
If you have an execution, will there always be 3 solutions?
The rule is for the fundamental theorem of algebra is when you're looking at x degree polynomial, we'll have x degree real roots. I'm looking at reals here, so I can have real zeros. I can have up to 3 real zeros. So depending upon the problem, this is what you can get. We'll talk more about how that intertwines later. All right? So, let's look at these. I want to factor both of these. Take a few minutes and work yourself through.
Easy.
No.
You do the
Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
Is this a subtraction symbol?
Yes.
What are my 2 terms? Once again, is this a perfect square? Is this a perfect square? Is that a subtraction symbol? What are my 2 terms?
3x minus 2, 3x plus.
Is this a perfect square?
Yeah.
Is that a perfect square?
Yeah.
Is that a subtraction symbol?
No.
I didn't do the difference of squares.
You did the long way?
Yeah, 3x minus 3 times 2 plus 6x plus 4.
Yeah. Oh, no. You thought it was a cube. It's a 4th one. You're thinking cubes, that's why. That only worked with the 3s, okay? Now the second one.
No way.
What's your first rule of factoring, ladies and gentlemen?
GCF.
Yeah. So if I'm looking at the second one, what's your GCF here? Okay. So if we go with the GCF of 4x squared, I get the following. On the inside, I have x to the 4th minus 5x squared plus 6. Are we okay with that?
Yes.
Now, we're looking at a normal-ish looking trinomial, right? On the inside of the parentheses. Look at your degrees of your exponents. It's going from a 4 to a 2 to nothing. Doesn't that mirror the idea of x squared, x, and some number? Can you factor it the same way? Try it. What times what is positive 6 that you add together to get negative 5? Okay, negative 3 and negative 2. Okay, so we know our numbers, our integer values are negative 3 and negative 2. What would the front halves have to be?
Square.
Right.
Screw up.
Because if you go through and you refoil that, you get x squared times x squared gives you x to the 4th. Minus 2x squared minus 3x squared plus 6. It works the exact same way as it would 2, 1, nothing as 4, 2, and nothing works. It works the same way. You use the same methods. Okay? The same exact methods for factoring. Oh, I do have to remember to bring down the 4x squared. I can't get rid of that 4x squared here, can I?
No.
It's not equal to 0, and plus, it's got an x with it. Okay? We can't discard that because there's a variable out there.
So you go from that choice and have it down the first one.
Second, we'll switch up to a couple other ones. Exciting.
Yeah.
We're not solving it. Did you see an equal sign yet? We'll get to it. We're factoring. We're going to get to the equal signs here pretty soon. Like maybe now.
Oh, darn.
So now what's changed? We have an equal sign, right?
Yes, we do.
What's going to change when you're done factoring them?
Solve zeros.
Solve for zeros. So with this being a 5th degree polynomial, how many possible zeros could we have? We could have up to 5 real zeros. So take a couple of minutes and figure it out.
Okay.
We did.
Oh, you had trouble.
I'm hoping, guys, I'm hoping your very first step was to go 2x to the 5th minus 14x cubed plus 24x and set it equal to 0. Right?
See.
Now, what's the first rule of factoring?
GCF. 2x.
Yeah, you gotta take the GCFs out.
No.
It makes your life a lot easier. Okay, you always want to put it in the descending order because now when you factor out your GCFs, you take out the 2x, you have x to the 4th minus 7x squared plus 12. And you see how it's mirroring that problem we did a little while ago where you had your degrees going from 4 to 2 to nothing? See how that works, Emma? Okay. By putting it into that standardized descending order, it leads you into other ways of doing things. Okay? So now we're at kind of like a normal trinomial looking thing, right?
Yeah.
All right, what times what's positive 12? You add together to get negative 7. Negative 4, negative 3. So you wind up with 2x times the quantity, x squared minus 4, x squared minus 3 equals 0. Now, I'm glad you're saying that, and Kay was saying the same thing. At this point, does everybody agree that I can factor this further and go x plus 2x minus 2?
Yes.
Do I need to for this specific problem? Why? Right. The reason that I don't need to factor this fully is because I'm setting it equal to 0. You can stop at that point of your factoring. You do not need to completely factorize. Whatever. You don't have to go any further. When you're solving for zeros, you don't have to do that. Now, if it said factor completely, then you would have to do x plus 2x minus 2. Here I can find all of my zeros. What's my 0 here? 0. What's my 0 here? What's my 0 here?
Those are minus the square root 3.
And you're done. Yes, you have to put the 0 here. Because if you look at it, what's that? Add 4, take the square root. Add 3, take the square root. Set it equal to 0. What's x equal to? 2 times what is 0? 0. Okay? Now, what Thomas was saying, I can't get rid of this 2 out front here because it has the x on it. Okay? If you got rid of it, you would lose a 0, and that would be bad. You don't want to lose a 0.
Well, when zero.
Okay? So try this one.
All right.
So that's it, just those.
Now, I'm sick and tired of doing math problems. Somebody else do it.
You can go right.
Just go!
Just do it.
That's, no, you can't say that. It's already copyrighted. You've been sued.
Whoa, Brett.
Rap. Rap.
Show your math in stages.
Rap.
Nah, let's do what he did with the American guy.
I'm gonna judge your organization of math. Wait, can you do another problem?
Wait. I know, I was doing something
You know, if you would have done the work prior to this.
I did. I just did like this and that.
I think I broke all four of them.
It doesn't make sense. 5 plus 4 is not equal 1, yet it equals 1.
Come on, Val. What do you think this is?
This isn't bad.
Is he right? No! He's wrong! All right.
I was wrong.
All right, what happens here, guys, is he set that thing up, and he just started skipping a couple of steps here, which is fine. If you recognize the pattern that's going on, it's no big deal. You wind up your 2 terms with 3x plus 7 and x squared minus 4. Both of those set equal to 0. You get plus or minus 2 and negative 7/3. Yes, ma'am?
I got it.
There is no plus minus there because there's nothing squared. You're not taking square roots or anything like that. Okay? You divide, you're at, what's that? Yeah, because you have to take the negative out, the negative divided by negative this. It's tricky. It's tricky. Do those. Same section. All right. Same section.
Same page, same time.
Let's say, where's my calculator? I
That's
remember.
13 of them.
It's too many.
Oh, woe is me, I finally gave you more homework.
I have so much like Mario and snapping over your
Really?
Can you put them on the board?
Yeah.
It's embarrassing.